So the last part of the stack is IPSO smart objects that run on top of lightweight MTM. And IPSO smart objects basically provide plug-and-play interoperability between applications and IoT data sources, sensors, actuators, and other gateways, for example. The philosophy with IPSO smart objects is to create a set of objects and resources that represent simple measurements in single points of interest, fundamental concepts, so temperature, pressure, on-off switch, things like that, and resources that represent single points within that. What's the current value of the temperature? What's the max value? What's the min value, etc. And the idea is to make the objects and the resources reusable across domains. So a temperature sensor only needs to be defined in one place, one time, and the temperature sensor you use in a washing machine could be the same as the temperature sensor you use to measure the room temperature. It could be the same as the temperature sensor you use to measure the temperature of the cooling water coolant in an automobile engine. So those can all be represented by the same IPSO temperature object, even though they represent temperature in very, very different situations. And the resources likewise are reusable. And for more complex things like an automobile engine or an electric motor, you would use a number of objects: a temperature object, a rotation object, a power supply object, voltage, frequency, vibration sensors. It would take a number of IPSO objects to make up a model of a complex thing like a motor. A very simple URI template defines the object. There's an ID for the object type itself, which has a semantic meaning. For example, 3303 means temperature. And there's a resource type for a number of resources. And in this case, the resource 5700 indicates current value. Also, there may be more than one instance of an object. There may be more than one temperature sensor in a device, so we allow for multiple instances. So this URI fragment reads as object type 3300, instance 0, resource 5700. So it's the current temperature of the temperature object 0 in this endpoint. And everything in IPSO objects is represented by the same two-level class hierarchy, with an object type that represents what's being measured, and a resource ID which indicates the attribute that's being displayed of the measurement: current value, min, max, etc. And since the object model here is the same as lightweight M2M, all of the IPSO smart object IDs are registered with OMA in their lightweight M2M object registry right alongside the management objects. So management objects and application data objects share the same protocols, the same semantic namespace, and the same registry. Also, there's simple data types and access types: read, write, create, delete, the standard CRUD methods, along with execute and discover. And the data types, really simple data types: string, decimal, Boolean, etc. So an example of an IPSO object: here's the temperature object. This object is object ID 3303. It has within it three resources. It has a sensor value, 5700. It has a min measured value, and it has a max measured value. And the idea is the min and max track the min and max of the measured value over time. So reading the current temperature value is a GET to resource ID 5700 in that object, so it's a GET to a URI of 3303.05700, and that returns the temperature value. The IPSO Smart Object Starter Pack is the first guideline published by IPSO, and it has a set of very simple starter objects that represent some simple base concepts like generic sensors and digital analog IOs, things like temperature, presence, sensor, humidity, light control, accelerometer, this kind of thing. So this is basically just an initial set of objects to show how smart objects can be used and to get people started. If you need more objects, it's really easy to create new objects yourself. And here's an example of an ad hoc object. OMA Lightweight M2M provides object ID space for experimental objects. And so here it happens to be an experimental object, the heart rate monitor that was built to represent a Bluetooth low energy heart rate monitor. And as you can see, every attribute, or as they call them in Bluetooth, every endpoint is represented as a different resource in this REST API. So it's really easy to map Bluetooth and Zigbee endpoints to REST APIs using these object resource class hierarchy here. Here's another example of the Nest thermostat represented as an IPSO smart object. And it's a little more complex and has a few more resources in it, but you can see that you can represent objects of fairly arbitrary complexity by using the same two-level class hierarchy. However, at a certain level of complexity, it's probably better to make a composite object of a number of simpler IPSO smart objects together to form this composite object. And that's really the philosophy of IPSO smart objects, is to build complex objects out of more simple objects. But still using the same two-level class hierarchy, so objects can contain links to objects, and that's how the composite objects are built. Also, IPSO smart objects can be semantically annotated, so using RFC 6690, whether you're using Lightweight M2M or other interfaces, you can add semantic links to smart objects. So here's an example of semantic links added to a temperature sensor so that application software can discover this through resource directory or through other core link format query operations. IPSO smart objects are really easy to develop, modify, and customize. The idea is we have a consistent design pattern, reusable resource definitions, and a really easy way of assigning new IDs. So an existing set of objects could be forked, copied, and modified to suit practically any domain. And we're expecting, as the new IPSO smart objects will be defined by collaborative working groups that are composed of industry representatives that are familiar with particular domain-specific vertical industries. So, for example, a set of IPSO automotive objects might be made by a committee that has some experience defining automotive APIs and etc. So new object sets will be released as new smart object guidelines, and all the guidelines will use a standard set of file descriptors and schema files. So the current roadmap is to first publish an expansion pack. So to build on the starter pack of basic objects, to create a comprehensive set of basic objects that represent most of the physical properties and simple devices that need to be represented. So in addition to temperature and humidity, we want to add pressure and depth and speed and direction and things of that nature, as well as on-off switches and light dimmers and other kinds of control interfaces. For domain-specific objects, we're working on a set of gateway management objects now for managing application layer gateways and transport layer gateways. And we're publishing a smart object design guide and technical reference that contains the description of smart object architectures and the schema used. So the expansion pack, as I mentioned, is going to add some new device types and some new concepts so that there's a comprehensive set of things that can be represented using IPSO smart objects. And in the future, beyond expansion packs, we're going to be publishing some domain-specific objects for gateway management and other domains. Object linking from device to device will be able to create virtual devices that contain resources from multiple devices. And there are a set of data model questions going forward that we need to create more complex data models that'll be provided for. Peer-to-peer device interaction. So currently we have only Lightweight M2M as a standard server specification. We need to come up with standard ways for devices to interact with each other between devices, and higher level semantics such that high level applications like analytics and what have you can map to lots of different kinds of sensors. And lastly, we're building IPSO smart objects that represent other object models, devices from other object model sets like Zigbee and Bluetooth, BACnet, etc. So to summarize, we have basically a set of IP, internet, and web-like protocols that can provide a modular stack going all the way from the IP socket layer to application software. We have CoAP, which is a REST protocol for constrained devices based on an IETF standard. OMA Lightweight M2M that provides a server middleware and device management and an object model. We have IPSO Smart Objects that provide application-level interoperability using a standard set of application-level objects. And that allows us to write application software that's not tied to any particular programming language, that can run on the devices, gateways, or services, can run anywhere, and provides this infrastructure for being able to connect any device to any service, regardless of the underlying protocols, as long as they use IP protocols. And a set of references for further investigation: the IPSO Smart Object Guidelines, OMA Lightweight M2M specification, and the related IETF specifications. Thank you.